students. Last class we have discussed about t-test in independent large sample. So today we will discuss about t-test for independent small sample. Here n is considered to be smaller when it is smaller than 30. So it will be a small sample. Now the formula for t will remain same, that is mean 1 minus mean 2 divided by standard error of difference. Now to calculate this standard error of difference, the SD formula for small sample is square root of summation of x squared by n minus 1. Now here we have two groups, so we can have two SD value and from that calculating standard error of difference. But rather than doing that, here we will take all the sum of square of deviation together and we will introduce a concept of pool SD, where the two SD values are taken together and then compute a single SD. So the concept of pooled SD will be used here. Now there are formula how to calculate pool SD, and from that pool SD value we will calculate the standard error of D. So the SD formula is equal to square root of summation of x1 minus m1 square plus summation of x2 minus m2 square and then n1 minus 1 plus n2 minus 1, and the standard error of D is equal to SD into square root of n1 plus n2 n1 into n2. So these two are the formula. Now we will take one practical question to find out how to calculate the standard error of D and T for independent small sample. First I will read out the question, that an interest test was administered to a group of 6 boys in vocational class and 10 boys in a Latin language class. Okay. Now after that their scores are found and we want to compare whether the mean difference between these two groups are significant or not. So an interest test was administered, so one group is the vocational class where n is 6 and next is Latin class where n is 10 boys are here. Now the scores are given, which is the capital X, it is 28, 35, 32, 24, 26 and 35, and then similarly here x2, the scores, that is 20, 16, 25, 34, 20, 28, 31, 24, 27 and 15. So these are the raw score which are obtained by these two different group of boys on a interest inventory. Now first what we will do, we will calculate the mean value for both the groups. So mean, how will here, this is total is 180 divided by 6, that's why it is 30. Here it is 200 40 divided by 10, n is 10, so 24. So from that we will find out the deviation from the mean values. So small x 1, this is deviation from the mean value of each score, minus 2, 5, 2, minus 6, minus 4 and 5. Here are the deviation values square, 4, 25, 4, 36, 16 and 25. So this summation of x1 square is equal to 110. Similarly for this group, mean 2 is 24. So we will find out the deviation. First 24, it will be minus 4, minus 8, 1, 4, minus 4, plus 4, 7, 0, 3 or minus 9. Now the square of the deviation, 16, 64, 1, 16, 16, 16, 49, 0, 9, 81. So total is 352. So after that we will calculate the pool SD. The pool SD value is summation of x1 minus m1 square plus summation of x2 minus m2 square divided by n1 minus 1 plus n2 minus 1. So here the values are this summation of x1 minus m1 square is this deviation value square total. So it is 110 and then for group 2 it is 352 and n1 is 6, 6 minus 1 is 5 and 10, n2 is 10, so 10 minus 1 is 9. So it will be 14 divided by 462. So it is 5.74. So this is the value of pool SD. Now we can find out the standard error of, so therefore standard error of D is equal to SD into square root of n1 plus n2 divided by n1 into n2. So SD value is 5.74 into 6 plus 10, 6 into 10, 5.74 square root of 16 divided by 60. So it will be 5.74 into 0.5196. So this is the standard error of difference, that is 2.96. So by putting this value we can finally calculate the T value. So T is mean 1 minus mean 2 and the standard error of D. So mean difference is 30 minus 24 and this is 2.96. So this is 2.0. So now here DF formula is n1 minus 1 n2 minus 1. So 5 plus 9 equal to 14. So now 14 DF table, okay, we can check the t value. Okay, so we'll check the t value at two-tail test. So t values will be at 0.05 level is, you can check the table, is 2.14, and at 0.01 level is 2.98. Okay, these are the values. So now you can compare that our obtained t value, which is 2.03, that is our calculated t value, is smaller than the t value which are given in the table, 2.14 and 2.96. So what we can interpret from that? Okay, we can interpret that our obtained t value is smaller than table values, therefore the t is not significant. This indicated that the mean difference is not significant. So you can see this way we write it down, the interpretation of the whole calculation, that we can interpret that our obtained t value is smaller than the table value, therefore t is not significant. In case our calculated t value is larger than the table values, then that value will be calculated. So we can have, sometimes we can have value which is larger than the t values at one level, maybe 0.05 level the value. So t value can be larger than the t value at 0.05 level but smaller than this 0.01 level value. So we will say that the t value is significant at 0.05 level but not at 0.01 level. So this way we will interpret our calculated value. Thank you.